So what you want to find? You want to find the current that is flowing through this 30 ohm resistor, and I want to use Norton's theorem and Thevenin's theorem. Okay, so when using Thevenin's theorem, just follow 3 steps. First of all, we have to replace the power source with short circuit. If there were any current source, we'd replace that with open circuits, and we're going to remove the load resistor. That is going to be the first step. So this one is the voltage, and it's 10 volts right here. And so if we do that, let's remove. That means we have replaced it with short circuit, and we still have our resistor. This is resistor 1, and we have our second resistor. Okay, so this is R3, and we have this resistor, which is R2, and we have removed the load resistor. So let's just call this terminal A, and this one terminal B. So this is 10 ohms, and this one is 40 ohms. This one is 20 ohms. So that is the first step, step number 1. So our second step, we need to calculate the Thevenin resistance. So calculating the Thevenin resistance is first of all, you have to know how to calculate the total resistance if you are given resistance in series or in parallel. So what we're going to do, first of all, it doesn't matter the side to start with, but in this case I'm going to start with the right side. I'm going to move from the right side to the left hand side. You can even start from this side. Okay, so I'm going to assume that I'm going to have the current here. So let's say I have the current, and I'm going to call it I. So this is going to be the current. What you happen, I is going to split right here. We're going to have, let's say, I1 here, and we're going to have I2 here. So that means if I say 20 ohm resistor, the resistance is going to be 20 ohms plus. So I know the resistance, the sum of the resistance is going to be the same as the current that is going to pass through these two resistors is going to be the same as the current that passes through the 20 ohm resistor. So that means all these two resistors are in series with this one. But let's look at these two resistors. This current I1 and I2 is never going to be the same, so that means they are parallel. So I'm going to say plus the sum of these resistors, 10 ohm, which is in parallel with 40 ohms. This resistor is in series with these two resistors. Because if I add this current and this current, I'm going to see it's going to be the same here. But the current is going to pass through 10 and 40 are going to be different. It's different. Okay. So we're going to have 20. So it's going to be the Thevenin resistance, 20 ohms plus. And if two resistors are parallel, the resistance is sum over, it's product over sum. So it's going to be 40 times 10 divided by 50. Okay. And what are we going to get? And if we say 40 plus 10 times 10, that will give us 400 divided by 50. That is 8. So we're going to have 28 ohms. Okay. And now what we're going to do, we're going to find what we call the Thevenin voltage. Okay. So Thevenin voltage, which is step number 3. So on Thevenin voltage, we need to find V, the voltage that is going to be between these two terminals. Okay, so when finding the voltage, you can use nodal analysis, you can use mesh analysis, you can just use Ohm's law. But since these are only two loops, we're just going to use what is going to be is. Okay, so what is going to happen here? I'm going to start from here. We know this is 10 volts, right? So from this point, I'm going to call it point A. It's going to be 10, the voltage is going to be 10 volts. Because don't have any voltage drop. But we're going to drop some voltage right here. And we're going to, let me just call this point B. So you can see, if you find the voltage along this terminal, it's going to be the same with the voltage right here. Okay, so what are we going to do? What we're going to do is, we need to find the voltage that is passing through the 40 ohm resistor. So what we're going to do, we're going to use, I think using voltage divider is going to be easy. So the voltage is going to be what? Let me just say Thevenin's voltage. Okay, so the reason why I'm ignoring this resistor, see, there's nothing here, there are no terminals, so there's going to be no voltage drop here. Okay, so it's 10 volts times, what is the voltage that you want? It's 40, so we're going to say 40 divided by the sum of all the resistors. It's 1, 2. It said there's no voltage that's going to pass through here, so it's going to be 40 plus 10. And if we say 40 over 50 times 10, that's going to give us 8 volts. Okay, so now we have everything we need. So if we have this, it's now easy to calculate the current that is passing through the 30 ohm resistor. Why? Because look, we're going to have our voltage, Thevenin voltage right here, and we're going to have the total resistance, which is Thevenin resistance right here, and now we can add our load resistor right here. Okay, so we said Thevenin's voltage it's 8 volts, and Thevenin resistance we said is 28 ohms, and now it is the load resistor is 30 ohms. Okay, and you just need to find the current, which is I. So it's now easy. You can use Ohm's law. You know that voltage is equal to IR, and for voltage we have 8V, and I we don't have I, but the resistance, these resistors are now in series, you can just add them. So it's going to be 20 plus 30, okay, ohms, and I, if we divide both sides by 50, it's going to be 8 divided by 50, and that is going to give us 0.16 amps. Okay, now let's use Norton's theorems and see if we're going to get 0.16.